Hello out there, Physics 277 students and anyone else out there on YouTube who may be watching this. This video will demonstrate how to use the G++, C++ compiler on the Linux command line to compile a simple C++ program. The G++ compiler is part of the GCC, the GNU compiler collection, and it is a C++, a fully featured C++ compiler, and we can use it to compile our C++ source code files into an executable file which can then be executed from the Linux command line. We'll cover more about this in class, but this is just an introduction that will get you started and show you how to use it. So let's look at what we have in this working directory here. I'm going to type ls and oops, there we go. We see I have a single file there, hello_world.cpp. And this will be a source code file for a very simple C++ program. Let me show you what is in this file as far as C++ source code goes. It's just about the simplest C++ program that I could write, consistent with good programming practice, and it just basically has 5 lines of source code in this. All it's going to do is write hello world out to the screen if I compile it and run it correctly. So how would I compile this, that is, turn it into an executable file that can be run by the shell, just like any other command that we have on Linux or Unix systems? Well, in order to do that, we're going to invoke the G++ compiler. And the command to do that is G++, just as the name would suggest. Okay, now G++ takes as an argument, in its simplest possible form, takes as an argument the file that contains the source code for the program you wish to compile. And that's what I have here. So I'll just supply that as an argument. So we'll say G++ space hello_world.cpp. Now I'll hit return or enter, and you can see it hesitates for a moment. It doesn't give me any output. But if I do an ls now, we can see in this directory there's a new file that is present. It's a.out. And by default, the G++ compiler names the output file a.out. Now this is sort of annoying a bit. We'll see another way around it later. I could execute this file now, and the easiest way for you to execute this, if you're doing this for the first time, is to type ./a.out, no spaces in there, and you can see it writes out to the screen, hello world. Not very impressive, but it's a beginning. Okay, now let's talk about a couple of things. First of all, why did it name the file a.out? Well, I didn't tell it what to name the executable file, so the default is it will name it a.out if I don't do that. There is a way I can tell the compiler what I would like the output file to be named. Now, the usual programming convention that people follow on Linux and Unix systems is that if you have a source code file named something like, file.cpp, then you would name the executable program file. Right? So the name is consistent with the source code file, meaning that in this case, a.out would be more consistent with this if I were to name it hello_world. All right, and I could do that by just simply doing a move here. I do move a.out to hello_world like that. Now, if I do an ls, you'll see I have 2 files. This is my source code file. It contains ASCII text, plain text, that has the statements in the C++ programming language. Right? The compiler processed this file and it turned it into an executable file which we can now run as a program just like any other command we would execute from the Linux command line. So if I said ./hello_world like this, it writes out hello world. Okay, so I can skip the step of having to move a.out to some other file name using the move command, right, or renaming that file, by supplying another set of arguments to the G++ compiler. Let me show you how that works. Let me first delete hello_world here with the rm command. And if I do an ls now, you'll see I have a single file sitting in this directory. Now I'm going to invoke the G++ compiler again, the way I did before, but I'm going to supply a second set of arguments to it. I'm going to supply a flag to it called the -o flag, and that's a minus lowercase o. Right? What the -O flag does, it tells the compiler the next argument to follow will be the name that I want you to name the output file. So in this case, I'll say hello_world like this, and when I execute this now, as I'll do, oops, I made a typo there, inserted a couple characters I didn't mean to, several characters I didn't mean to. When I hit enter, now it will execute, and you can see it produced hello_world. Now, there's no law that says you have to name this the same thing that you named the source code file. All right, I could, for example, name this output file Robert like this, and do that, and you would see there would now be a file named Robert there. Right? It's kind of silly to do that, so we generally don't do that. We would typically name the executable file after the same name that we had the source code file when we had something simple like this, where the source code file was packaged up in the source code for the program was packaged up in the same file. So in that case, I would typically say G++ -O, and then whatever the source code name is without the C++ extension. So like that. All right, when I do that, now I have that. I don't want the Robert file. Let's get rid of that. All right. And there it is. If I want to execute it, I can type /hello world. All right. Now, that worked. Why did I have to type the /? Well, it has to do with the way you have your shell set up or maybe not set up. And that's a result of what we do with our path variable. If you haven't seen the video I've made about shell variables, environment variables, and setting your path, right, I'm going to put a link to that in the end of this video in the upper right corner, and I suggest that you go look at that. When you want to execute a program in the shell needs to know where to find that, and it has a list of directories that it checks where to look for programs, and that's called a path. And in the other video that I referenced, I talk about that in greater detail. So what I'm doing in order to execute it here, when I type /hello world, is I'm specifying a relative path to the current working directory. Remember, if you haven't seen it in one of my earlier videos where I talked about relative and absolute paths, all right, relative paths are paths that start relative to something. So dot is the symbol the shell uses to represent the current working directory. So by saying /, I'm telling the compiler, the shell, to look in this directory for this command that I'm about to give you. In this case, it's hello_world. All right. Oops, I keep mistyping world. There we go. And that's what allows that to run. Now, if I have added my current working directory to my path, which you may have done if you've already seen the video where I talk about environment variables. In that case, I can just execute this by typing hello_world. All right. In that sense, it's no different from ls or any other Linux or Unix command. When I give that command to the Linux command line interface, that is the shell, it simply searches a list of directories. As soon as it finds that, it executes it, and that's what it's doing here. So if you'd like to be able to execute your program without having to type // in front of the name, then I suggest you set up your shell variable. Take a look at that other video. So that's going to be all for this video. It's just a simple introduction about how to invoke the G++ compiler. If you have any questions, if you're one of my Physics 277 students, please come and talk to me during office hours. I'll be happy to chat with you about it and show you more about it. We'll use G++ in a more complicated sense later when we start separating compilation and linking into different stages, and we split our program up into multiple files. We'll deal with all of that later. If you have if anyone else out there has questions, or you can't see me during office hours, feel free to post a comment. And otherwise, I will see you here next time.